Okay, so to find absolute value functions, we need to first of all consider what taking an absolute value of a number means. So to take the absolute value of a number, for example, if I have the absolute value of 2, is just 2. Absolute value of minus 2 is 2. The absolute value of x is x. The absolute value of minus x is x. So all the absolute value function does is gets rid of any negatives and makes them positive. So if we were to consider the graph y equals x, well, we know the graph y equals x looks like that. If I took the absolute value of x, all it does is get everything that's negative, gets rid of that, and makes it positive. So my graph, if I make that maybe a bit larger, my graph is that red bit there. That's y equals the absolute value of x. If I considered the graph y is equal to the absolute value of x plus 1, that would be that. And if I had, say, the graph y equals x plus 1, well, that looks like that. So that's y equals x plus 1. If I then took the absolute value of y equals x plus 1, all of my negatives would go up there and become positive. So that's y equals x plus 1. They're kind of like parabolas, but they're a bit more pointy. So let's consider what happens if we take the absolute value of a given function, like this parabola here. Well, if we wanted to find the absolute value of that function, we first of all need to draw the parabola. So we can factorize that parabola and get x minus 3, x minus 1, make that equal to 0. We'll get our solutions of 3 and 1. So 3 and 1, and my y-intercept is 3. So that's my parabola there. All an absolute value function does, everything above the x-axis remains the same, and all the stuff below the y-axis is just reflected up like that. So in the red, this is the graph y is equal to the absolute value of x squared minus 4x plus 3. In an exam, I would then go across or somewhere and draw it more neatly, so that looks something like this. Okay, let's do another example. I know I didn't leave much space. I might do it here. Let's say we've got this funny looking function here. Let's say maybe that's a cubic function, a positive cubic function. If I were to say, let's say this was y equals f of x, to take the absolute value of that function, y is equal to the absolute value of f of x, all that happens, all of this remains the same. This goes up here. This remains the same, and then that goes up like that. So the original function is the blue bit, and then the red bit is my absolute value function. So all it does is reflect everything on the bottom up to the top. Okay, what if instead of saying y is equal to the absolute value of f of x, what if instead we said, what happens when y is equal to f of the absolute value of x? Well, it's quite similar actually. We're going to draw our original parabola, which had intercepts at 1 and 3, and then it had a y-intercept of 3. So that parabola, that's awful, that parabola is going to look something like that. That's my parabola. That was my original parabola. If we think about what this means, y is equal to f of the absolute value of x. What that means is all of our negative x values, well, that's going to be 2. The absolute value of minus 2 is 2. The absolute value of 2 is 2. So all of my x values, whether they're positive or negative, are going to result in the same y value. So what that means is all of this is going to go. Everything to the left of the y-axis is going to go, and then since our negative values have to input the same y value, then this is going to happen. It's going to reflect. So all that's happening is I delete everything on the left of my y-axis and then reflect everything on the right over to the other side. So next question, we're going to sketch y is equal to the absolute value of x, f of x, and then we're also going to sketch y is equal to f of the absolute value of x, for f of x is x minus 1, x plus 3. So if we consider that function, well, it has zeros. Remember, zeros, x-intercepts, and solutions all mean the same thing. It's going to be 0, 1, and minus 3. So I'm going to go down here. Oh, let's rub that out. I'm going to go down here and graph that. So 0, what was it? 0, minus 1, and 0, 1, and minus 3. We know it's a positive function, so it's going to look something like that. To take the absolute value of that, all we're doing is getting everything on the bottom and putting it up the top like that. Everything that's on the top of the x-axis remains the same. All that's happening is this bit is going up here, for example. I want to rub that out. There we go. So that's our red function there. If we redraw our equation, so it was 1, 0, and minus 3, and it was positive, so it looks something like that. Well, if we're going y is equal to f of the absolute value of x, our first step is to remove all of this. And then all I need to do is reflect all of that. That's not a very good reflection. All of that up like that. That's all you have to do. So all we're doing is deleting everything on the left-hand side of the y-axis and then reflecting it. Now it's important to consider our original function had a y-intercept of minus 3. Our reflected function is not, this is not going to be minus 3 here at this point. It's not minus 3. It's going to be minus 1 because it's an exact reflection of the 1 that occurs over here. Alright, I'd like you now to complete all of exercise 709. Awesome, hope that makes sense.